Hi guys, it's Mrs. Seitz, and today you guys are going to be learning how to factor polynomials using the greatest common factor. The other thing we're going to be doing towards the end of today's lesson is also how to find a least common multiple using a couple set of factors as well. So what's factoring? Factoring is writing a polynomial as a product of factors. So it's kind of like the flip-flop of what we were doing before. So before you had the actual, two binomials that you were multiplying together, and then we had to multiply them out to get our final answer. Now it's kind of like you have the final answer and you are working backwards to see almost what the original problem was, okay? We're going to do that first and start that process by finding out what the greatest common factor is of each polynomial. To find the greatest common factor, or GCF, you're going to first try to identify the greatest factor of the coefficients and the constants, and then identify the smallest of the exponents. Then you would use the distributive property to write the polynomial as a product of the GCF and its remaining factors. Now, that's one way you can do this. The other way is, I'm going to show you a way you can do this almost by looking at it in terms of division, and then you can find your greatest common factor a little bit faster. So what I'm going to do is I'm going to write down, like by looking at our first problem, this 4x squared plus 12, and I'm going to write an upside down division box. And what I want to do right now is I want to see, looking at the 4x squared and the 12, what's the biggest number that I could take out of 4x squared and 12? So the biggest number it looks like that I can divide out of 4x squared and 12 is a 4. So 4x squared divided by 4. Well, 4 divided by 4 is going to give me 1, and then I'm just going to drop down my x squared. 12 divided by 4 is 3, and I'm just going to bring down my plus sign. All right, now, in terms of what I have left over, you actually have factored your greatest common factor out of your problem, because when you look and see what's left over here, you have this x squared plus 3. The greatest common factor that you could divide out of them, well, there's no more numbers that you can divide out of them, and the 3 doesn't have an x with it, so we can't take anything out between the two of them other than a 1. So when we have that, we look right over here at the side. When we look over here at the side, the number that's hanging out on the side here is actually our greatest common factor. So the greatest common factor between 4x squared and 12 was 4. And we're going to write this now in factored form. Well, how we're going to do this? We're going to take our number that we have on the outside, which was 4, and we're going to put it on the outside of a set of parentheses, but put the number that we have, or the set of polynomial that we have, underneath it in parentheses. So we're going to have x squared plus 3 in a set of parentheses. And you can check to see if you did this correctly, because if you distribute the 4 back through, you're going to get the original problem. So if I did 4 times x squared, I would get 4x squared, and 4 times 3, I'd get 12. Let's try another one. So if you have 21 n to the third minus 18 n squared, first thing I'm going to do is I'm going to look and see what's the biggest number that I can divide out of those. The biggest number that I can divide out of those would be a 3. Okay, 21 divided by 3 is 7, and I'm going to bring down the n to the third. 18 divided by 3 is 6. I'm going to bring down the sign with it, and the n squared. Now, just looking at the numbers, I can't do anything more between a 7 and a 6, so I'm going to move on to the variables now. Okay, between the variables, I have an n to the third and an n to the second. The biggest amount of variables that I can divide out of the two of them is an n to the second power. So what I'm going to do now is, if I had 3 n's and I took 2 out, I would have 1 n left over. If I had two ends and I took two ends out, I have no ends left over, okay? So I'm not going to write any other ends in this space that I have right here. But I do have a 7 hanging out in the front here, and I do have a -6 hanging out here. So I am going to drop those down into my answer. All right, and when I look at the 7n and the -6, I want to see if I can keep going with this upside down division process. I don't have anything that I can divide out between a 7 and a 6. I don't have anything out in terms of the variables that I can divide out, so I'm done. So where do you find that greatest common factor? Over here on the side, okay? The greatest common factor in our problem is 3n squared. So we're going to write that over here on the side. And then we do the other part of our answer in a set of parentheses. So 7n minus 6. So again, our final answer for this problem in factored form is 3n squared times the quantity of 7n minus 6. I'm going to do the next problem on a separate slide just because I'm running out of space. Okay, so on our next one, we have 6x squared plus 36. So I'm going to write that down, and I'm going to do it in an upside down division box. Okay, what's the biggest amount of numbers that you can divide out between a 6x squared and a 36? It would be a 6. Okay, so 6 divided by 6 is 1, and then I'm just going to bring down the x squared. 36 divided by 6 is 6, and I'm going to bring down the plus sign. Okay, in terms of the variables, I don't share a variable between the x squared and the 6, so I can't do anything with the variables. There's no number that's common between an x squared and a 6, so it looks like I found my greatest common factor. The greatest common factor in my problem is a 6. So if I write this in factored form, I'm going to write down 6 times the quantity of x squared plus 6 for my final answer. Okay, and for part D, the original problem is 4y squared minus 36. I'm going to look for the greatest common factor that I can divide out of that. So the greatest common factor I can divide out number-wise looks like it would be a 4. So 4 divided by 4 is 1. I'm just going to drop down the y squared. You could put a 1 there if you wanted to. Negative 36 divided by 4 is negative 9. Okay, when I keep looking at this, okay, I can't really do anything with the variables, so it looks like I'm really done right now. So the greatest common factor I have in this problem is 4. And I'm just going to write y squared minus 9. Now, just so you guys know, this y squared minus 9 actually can be factored down further, okay? It will be factored down into something that looks like this in the future. But for right now, I'm just going to have you guys leave your answer as this, just so that you're not confused, okay? All right, now what we're going to do is we're going to go and use this idea of greatest common factor, and we're going to apply it now to an equation. And we're going to solve an equation by factoring, okay? So now we're going to have an x squared term in a problem, and we're going to be able to solve it now with this factoring process. So if you take a look at our first set, we have some blanks that we need to fill in our notes. So it says we're going to set the equation equal to 0. That's our first step. Anytime we have an equation with x squared, we have to set the equation equal to 0. The second step is we're going to factor our polynomial. And then we're going to set each factor equal to 0 and then solve. Okay, so when I take a look at part A, okay, the first thing in my checklist that I need to do is set the equation equal to 0. So what I'm going to do is I am going to move this negative 18w over to the same side that has the 2w squared. And I'm going to do that by taking the opposite operation. So I'm going to add 18w to both sides because I see a minus sign there. Okay, so I know 2w squared and 18w are not like terms, so I'm just going to put them side by side. I'm going to bring down my equal sign, and I'm going to cross out the negative 18w and the positive 18w because those canceled out to 0. So I did my first step. The next thing that I need to do is I need to factor out my polynomial, and this is where the greatest common factor comes into play. So we have our 2w squared, I'm going to do this off to the side, plus 18w. I'm going to do my upside down division to help me with that. So the greatest common factor between 2 and 18 is a 2. I'm going to drop down the w squared. 18 divided by 2 is 9. I'm going to bring down my w. Okay, the greatest amount of w's that I could take out between the two of them is just 1. So if I had 2 w's and took out a w, it would be 1 left over. I'm going to bring down my 9. If I had a w and I took a w out, there'd be no w's left over. So down here at the bottom, I would have just w plus 9. So when I'm looking at my factored format, I would have 2w on the outside and w plus 9 on the inside, and that would equal 0. Okay, so this is just like what I just showed you guys with greatest common factor. Okay, the only thing that's new about this now is we're going to set each one of these equal to 0, just like you learned in the other day's lesson. So I'm going to set 2w equal to 0 and w plus 9 equal to 0. All right, if I divide both sides here by 2, I'm going to get w is equal to 0. If I subtract both sides here by 9, I'm going to get w is equal to negative 9. So the two solutions I'm coming up with in this problem are w is equal to 0 and w is equal to negative 9. Okay, I'm going to take a look at the next one. I know it's going out of order letter-wise, but I'm just going to do this for my purposes. Let's take a look at C. All right, for C, we have 6x squared plus 18x equals 0. So this one is already set equal to 0, so I don't need to worry about moving things around. I'm going to move on to step 2, which is factoring. So I have 6x squared plus 18x. Got to find my greatest common factor. So the greatest common factor looks like so far number-wise is a 6. So 6 divided by 6 is 1. Drop down your x squared. 18 divided by 6 is 3. Drop down your x. Biggest amount of x's in each term is an x. So x squared divided by x is x, and 3x divided by x is just 0 x's, right? Because if you had an x and you took an x out, there'd be none left, so there'd be a 3 here. Okay, so the factored form of this would be 6x times x plus 3, and that would be equal to 0. Okay, if I look at the third step, I have to set each one of these factors equal to 0. So I would have 6x is equal to 0, and x plus 3 is equal to 0. Okay, dividing 6 to both sides, I get x is equal to 0, and subtracting 3 to both sides, I get x is equal to negative 3. So the two answers I'm coming up with are x equals 0 and x equals negative 3. We're going to try one more together, and then I'm going to have you try out the next couple on your own. All right, let's look at this one, letter E. Okay, I have 8z to the second equals 8z. So this one is not set equal to 0. So I'm going to move the 8z over to this side by subtracting 8z to both sides. I know that 8z squared and negative 8z are not like terms, so I cannot combine them. Okay, so I have the equation 8z squared minus 8z is equal to 0. I'm moving on to step 2 where I have to factor. So 8z squared minus 8z is the term I want to factor. So divide 8 out of those, you get z squared minus z, because 8 divided by 8 is going to give you a 1. The biggest amount of z's is a z in common, so you have 1z. If you had 2 z's, take out 1, you have 1 left over. Z divided by z, though, if you have a z and you take them all out, There's technically nothing left over there, but we have to have a 1 as a placeholder. Okay, so just remember that whenever you take everything out, you have to put a 1 as a placeholder. So 8z times the quantity of z minus 1 equals 0. We're going to set them each equal to 0 and solve. So 8z equals 0. Divide both sides by 8. You get z is equal to 0. Z minus 1 equals 0. So we're adding 1 to both sides. Z will equal 1. So your two answers are z equals 0 or z equals 1. Okay, now it's your turn. I want you guys to try out these ones. So I want you guys right now to try out B, D, and F and see if you guys can come up with the right answers on these ones. Okay, let's see if you guys got those right. So if you take a look at B, the first move I would have done was subtracting 5y to both sides. If you subtracted the 15y squared, not a bad idea either. Your answers in your work just might look a little bit different. We just will still come up with the same answer though. You will still get y equals 0 and y equals 1/3, okay? So if you do it my way, though, it's always good to start off with a positive coefficient in terms of standard form. So that's why I like to have the 15 with the y squared be positive, but your call, whatever you want to do. So when I did that, I ended up with 15y squared minus 5y. I then factored it here down at the bottom, and I came up with what you see here. And I came up with 5y times the quantity of 3y minus 1, setting each one of those equal to 0. And I have two answers, y equals 0 and y equals 1/3. For this one, it was already set equal to 0. So I went right into factoring. Greatest common factor here was 3x. So I set that equal to 3x times the quantity of x plus 7 is equal to 0. Set each one of the factors equal to 0 and solve them. And I got answers of x equals 0 and x equals -7. For F, same reason why I subtracted from the left side instead of the right side as why I did in B. I subtracted 18y to both sides, and I came up with 6y squared minus 18y is equal to 0. Factored that, and I came up with 6y times the quantity of y minus 3. Set each one of those factors equal to 0, and I came up with two answers. I got y equals 0 and y equals 3. And again, if you move the 6y squared over, that's perfectly fine. It just means that your answers or your work is going to look slightly different than mine, but we will still come up with y equals 0 and y equals 3. Okay? All right. In the next video, we're going to still use this idea of upside down division, but we're going to be looking at least common multiples of polynomials as well.